everyone, welcome to this video all about geometric operations, which is a type of measurement and data question. Today in this video we're going to be concentrating on a focus called surface area. Surface area is the total area of the outermost part of an object. It's easiest to think of surface area as the area of the net of an object, or the sum of the area of all the faces that make up a three-dimensional object. For example, a cube's net is made of 6 of its squares. The surface area is 6 multiplied by the area of one of its faces. Surface area questions are focused on 3D shapes and require knowledge on their properties. Okay, so surface area is exactly what it sounds like. It's the area of the surface that makes up a 3D shape. So even though these questions are to do with 3D objects, the actual way you solve the questions are much more related to two-dimensional objects, because 2D shapes are what makes up the net of the 3D shape, and that's what you need to know to calculate the surface area. So we're given one of the examples of how you might find the surface area of one type of shape, and we can see how important it is to know exactly how an object can be formed from a net into a 3D object when you're calculating surface area. So knowing that a cube is composed of 6 identical squares making up the cube really helps us in figuring out the formula, which is just 6, which is the number of sides in a cube multiplied by the area of one of its faces. So exactly like this concept with the cube, if we know the nets of all the common 3D objects that you might come across, it's going to be fairly straightforward when we try and figure out the surface area for those shapes. So for example, if we start off with general prisms, so that would involve you finding the area of the base shape. So let's say we have a bit of a random triangular prism. We know that these triangular prisms, if we draw out the invisible sides as well, or with the case of any prism really, they're composed of 2 of these base shapes, and then the rest of the shape is composed of these rectangles. So if you made the net of this shape, we would have this 3 rectangles and 2 triangles, or whatever the base shape is. And the number of rectangles that would of course depend on what the base shape is as well. If we figure out the area of the triangle and we figure out the area of the rectangle, we can very easily figure out the surface area. It would be 2 times the base shape, so the triangle base times height times half, plus the area of the rectangle, which would just be length times by width. And that would have to be multiplied by the number of rectangles present. And that can generally be applied to all prisms. A different 3D shape would be, of course, our pyramids. Oh, and just before I mention pyramids, cylinders would also count in the prism section, since they're essentially types of prisms, but we've got circles instead of different geometries as a spaceship. Now back to pyramids. Pyramids are also quite similar in concept. We've got let's say we've got a square pyramid this time. A square pyramid is going to compose of one base shape, which is usually a square, but it can be other shapes. So that would be length times length. And we've also got the triangles as well, which is also base times height times half. And if we expand upon the pyramid, it would then look with like a square in the middle, and it's got all these triangles connected to it. So we can see that we would need to find the area of 4 of these triangles and 1 of the square, or whatever the base shape is for that type of pyramid. Now the last shape that can appear, which is a bit rare, but we've got a sphere. And the sphere has its own kind of equation. And if we know the volume of a sphere, 4 over 3 pi r cubed, we can figure out the surface area because they're quite similar. You can kind of imagine as cancelling out the 3 and bringing it down to a 2 to give you 4 pi r squared. Those would be the more major kind of surface area questions to think about when you are dealing with these questions. So let's take a look at this example question here. Here we see Jimmy is painting a cubic puzzle like the below image. We need to figure out how much does he actually paint. So based on the diagram, we can assume that the puzzle is made out of these unit cubes, and unit cube just means that all 3 of its dimensions are all 1 centimeter long to give us the total volume of 1 centimeter cubed. So that makes the question a bit easier to deal with since we don't have to do as many calculations since everything is just 1. Okay, so taking a look at this cubic puzzle, we are obviously dealing with a cube, and we talked about what the formula for finding out the surface area of a cube was. It's just going to be 6, SA, standing for surface area, it's going to be equal to 6 times the area of the square. Now, in this case, it looks like he's only painting a portion of the face. So if we take a look at the face, it's got a grid on it. And only 1, 2, 3, 4, 5 out of the 1, 2, 3, 4, 5, 6, 7, 8, 9 squares are actually colored in. So we actually need to adjust this formula a little bit since not the entire face isn't being painted. Only 5/9 of the entire face is being painted. So that means the amount of space that is being painted, since they're all 1 centimeter cubes, each of these squares are equal to 1 centimeter squared. So this will, since 5 out of the 9 are being shaded in, that's equal to 5 centimeters squared shaded in per face of the square instead of 9 centimeters squared it would have been if you painted the entire face. So because of that, this area of the square face is going to be this value rather than this one. So let's do the equation with that adjustment made. The surface area is equal to 6 times 5 centimeters squared, so that results in the answer being 30 centimeters squared, which gives us option C as the final answer. Okay, so that was all of the techniques that we utilized to figure out the answer in this question. We realized that the surface area is just the total area of the net of the object, and applying that knowledge allowed us to figure out the answer. Hopefully this video helps you out in answering future surface area related questions. Thanks everyone so much for listening.